Okay, so I'll post the recording likely tomorrow morning is when you can expect it on the news feed. Yes, so let's review exercise or assignment 2. Bring that up. Okay, so everyone can see my spreadsheet from assignment 2. Anybody? Yes, okay, good. So question 1 was, what's the labor cost for an employee that works the following hours for 1 week? So you're given 2 different work weeks, person A, person B. You were given that their hourly cost is $38.75, including any and all burdens. So what that means is you don't have to add additional dollars per hour for things like CPP and EI and holiday pay and et cetera, all that stuff. The $38.75 was the all-in hourly rate. So looking at person A, these were their hours, so total of 50. So 8 hours on every day, except for Tuesday had 10 and Saturday had 8 as well. So what I like to do is I like to use a spreadsheet in questions like this, or you can set up a pencil spreadsheet with pen and paper. So I bring down all of the 8 hours. So up to 8 hours is straight time. So ST stands for straight time. So Monday through Friday, all of those 8-hour days are pulled down. Only 8 of the 10 hours on Tuesday are brought into straight time. And then because the total of those 5 days times 8 hours equals 40 hours for the week, anything in addition to that is no longer straight time, it's overtime. So the Saturday has no overtime, or sorry, no straight time. So then what you would do is bring down anything that's over 8 hours. So you have Tuesday, there should be a 2-hour time and a half here. And then the entire Saturday was also time and a half. Everything else is zeros. So then the subtotal column subtotals all of those hours. So you have 40 straight time hours and 10 time and a half hours. Before I show the total dollar amounts, I'll do the hours breakdown for person B. I've got the calculation over here. I'll show that in just a moment. So person B had slightly different hours. The total is still 50. You can see the different hours here. So again, I do the same exercise with the straight time. Bring down up to 8 hours each day. So that's the first row. So we have a subtotal here. So that's the first 40 hours, that's straight time. So then again, the next row is anything more than 8 hours, but less than 12. So for Wednesday, you've got 2 hours here, so up to 10. For Thursday, you've got 4 more of time and a half. So that's up to and including 12 hours, right? So 8 and 4 is 12. Friday is the 2 hours past 8, so it gets you to 10. The Monday, Tuesday don't have any. So we would total that row here. So just total of those. So then what are we missing? So we're missing this Thursday Anything more than 12 hours, so 13 or more hours, is double time. So DT is double time. So Thursday is the only day with double time on it. Again, you could total that row. So there's your total hours. Same thing here. So now I will show the calculations. So back up to person A. So 40 hours times 1.0, so meaning that's straight time. So I'm multiplying by 1, and then times the hourly rate gives you a dollar amount. So then the time and a half calculation, so the 10 hours here is 10 hours times 1.5. That's the time and a half factor. So 10 hours at 1.5 times, and then multiplied by the hourly rate gives you that total, and then simply add those two together, and there's your total cost for that person A, $21.31. So similarly down below, again, the 40-hour calculation is the same. The time and a half is 8 hours times 1.5 times 30 is 75. And then the 2-hour overtime, or double time, I should say, is 2 hours times the factor of 2.0, the overtime factor, and then again times the hourly rate. Again, gives you another subtotal. So you add all those together and it's $21.70. So you can see they're similar total dollar amounts, even though they work the exact same number of hours. It actually costs more for this person due to the double time here. I see there's a couple questions. Joy Deep, give an assignment where measurements are already given. So you can look at your drawings on PDFs, right, on your screen. I can't give you dimensions. Part of this class is being able to read drawings. So you need to be able to do that. Whether you're reading them on your computer screen, that's fine. But everyone needs practice looking at drawings. Next question, not able to complete. So it looks like a similar question to the previous one. So again, you can look at your drawings on your computer screen. Okay, so back to assignment 2. So question 2 was, so what's the blended hourly rate, meaning the rental cost plus the operating cost for Concorp's front-end loader as part of the crew that was given. Whoops, undo that. Unhide. There we go. So the crew was working multiple months. There were 17 weeks, I believe the question said. So the best rate to use is the minimum monthly amount. So the front-end loader said the minimum monthly rental was $4,000 per month. So what we're trying to do with this question is the loader was going to work 15 hours per week, and the rest of the crew was going to work 40 hours per week. So in any given week, the loader is working, of course, far fewer hours than the rest of the crew. What we were trying to do is, in our estimate, have the loader included in the crew and multiply the entire crew by 40 hours. So what that means is you have to prorate or reduce the hourly cost of the loader because it's not working the full 40 hours per week. So how did we do that? First, we calculated the rent per hour of the loader. So the minimum monthly rent was $4,000, and we divided that by 40 hours per week of the crew times 4 weeks. So we're dividing by 160 hours. So 4,000 divided by 160 gives you $25 per hour. The operating cost, the next one down here, we were given an hourly operating cost of $48.50. So we take that actual cost per hour to operate the machine and multiply that by the number of hours that the machine is working per week. So 48.50 times 15. So we take that answer that we get and divide it by the number of hours that the crew is working. So we're dividing by 40 hours per week. So that's where we get the prorated operating cost for the loader. So that calculation turns out to $18 and change. So simply adding those two together, the 25 and the 18.19, gives you this $43.19 per hour blended rate for the loader. So just to show you an example of how I would anticipate this to work. So let's say, move this over so things are closer together. Let's say this is our crew. So we have an excavator, $40 hours a week. We have labor, another 40 hours a week. And then here's our loader. I want to multiply the loader times 40 hours a week. So this is the hours per week column. This will be the dollars per hour column. So all of these, so the labor, let's just punch in some quick numbers here. The excavator, labor. So for the loader, this is where we would put our prorated dollar amount in. So the 43.19. We've got it in our crew at 40 hours because that's what the crew works, 40 hours per week. But the labor is only, sorry, the loader is only going to operate or run for 15 hours a week. So we need to reduce its hourly rate accordingly. Nima, I'll get back to you on your feedback. So question 3, what is the per meter supply cost for 48-inch diameter HDPE pipe given the following? So unhide this one. So we're told that pipe costs $5,000 per 40-foot length. So each pipe is 40 feet long. So we're looking for the per meter cost. So we want to, so 5,000 divided by 40 feet, that'll give us $1 per foot cost. So we need to convert it into meters. So then if we divide again by 0.3048, so that's meters per foot, we get a subtotal of $410.10 per meter. That's just to buy it. Okay. So now we have to add PST to that number. So PST tax applies to materials. It's 7%. So you should make a note of that if you don't know that. It'll show up on tests. So to add 7% to this $410, simply go 410.10 times 1.07. So that gives you this new value that includes PST, so 438.81. So then we're not finished yet. So we have to add in the trucking cost. So in the question, you were told it's $1,700 per truckload. Now I verbally told everyone in week 2 that each truck could carry 4 lengths of pipe, so 4 pieces of pipe. That was not written in the question, so you had to be listening when I was saying that. So for the trucking, $1,700 per truckload, so 1,700 divided by 160 feet on a truck, and then again convert to meters. gives you a trucking cost of $34.86 per meter. So then you simply add these two numbers together down here at the bottom, and you get the total of $473.67 per meter. So that's your pipe cost supplied to your job site, including your PST tax. You always want to include PST tax in your estimates. We'll get into how to show GST a little bit later. We'll see how that's done today. But for PST, it's included in all of your bid items that have materials. So question 4, complete a quantity takeoff of the materials for the parking lot. Solve for the following. So you were given a table, and you were also given some information at the bottom of that table. So you were told the parking lot was 1,600 square meters. You were told some information about the existing grade being the same as the design elevation for the parking lot. So the new pavement elevation is the same as the existing ground elevation. Grade means, so that word means the underside of the subbase layer of gravels, you were told. Then lastly, I verbally told everyone what unit weights to use for gravels and asphalt. Now I want to make a point of this. I told everyone to use 2.0 tons per cubic meter for base gravel and subbase gravel. And I also said 2.45 tons per cubic meter for asphalt. Now, some of you did not use those conversion rates. Some of you used unit rates that were provided in previous terms. It's clear to me that some of you used answers from previous assignments from previous terms. There's no doubt in my mind that that happened. So going forward, I can tell when you're using answer keys from previous terms. My intention is to provide new facts as we go through assignments, new information for you to use in the assignments. If you're using information that I didn't say that happened to show up months ago or years ago in previous terms, then I know that you're cheating. And you will receive 0 going forward. So I want, hopefully everyone heard that, because you won't get any more warnings. Okay, so that table, I will unhide it. So topsoil stripping. So you were told in the table that the topsoil was 100 millimeters thick. So 1,600 square meters times 0.1 is 160 cubic meters. Excavate to grade. So as was stated in the information for this question, the pavement elevation in the existing ground is the same height. So in order to excavate to grade, again, grade meaning the bottom of the subbase layer, you would have to dig down the thickness of the asphalt, the thickness of the road base, and the thickness, of the subbase layer. So that the sum of those is 365 millimeters. Now, because you've already stripped 100 millimeters in this first row, this first item here, you don't actually deduct 365, you only deduct 265. Sorry, you only cut 265 deep. That's 0.265 meters. That's what this note means here. So your excavation depth is no longer 0.365, it's now 0.265 for this item. So 1,600 times 0.265 is 424. The subbase, so you would have to, again, you would have to look on a cross section for the parking lot where you were told the sub base is 200 millimeters thick. So again, it's just area in square meters multiplied by the depth in meters. So 1600 times 0.2 gives you 320 cubic meters. So this next one was the purchase of the gravel. So the purchase of the sub base, it's measured in tons. So this is where you would take the cubic meters that you calculated in the previous item and multiply it by the conversion factor that I gave everyone. So the 2.0. So 320 cubic meters times 2.0 tons per cubic meter gives you 640 tons. That's how much gravel you would buy for the sub base. So base is a similar calculation. Again, 1600 square meters. You would look at your cross section for the parking lot, see that it's only 100 thick, not 200. So you'd multiply by 0.1, give you 160 cubic meters. For the tons purchase, so again, 160 cubic meters multiplied by 2.0 tons per cubic meter gives you 320 tons. The asphalt cubic meters, again, so 1600 square meter area multiplied by the thickness of the asphalt. Again, from the cross section, you're told it's 65 millimeters. So 65 millimeters as expressed as meters is 0.065 meters. So multiply those out, you get 104 cubic meters. The asphalt, so the tons that you're purchasing, so 104 cubic meters times the density conversion, so times 2.45, gives you about 255 tons of asphalt. The curb is, so you had to measure the length of the curb with your scale. So that was 316 meters. Some people used AutoCAD, that's fine. I mean, in today's technological world, using software to measure is far more convenient, it's quicker, it's easier. There's various software that you can use. I'm not going to mark you wrong for doing that. That's not cheating. Catch basins, there was only actually 4 of them. If I bring up the drawing, the parking lot, yes. So let me just share this new right here. So here's the parking lot, storm sewer. So there's 1 here, 2, 3. There's only actually 4 catch basins inside the parking lot. This one out here is not in the parking lot. So the correct answer was 4. So I'll go back to my spreadsheet. There we go. Okay, so that was the end of question 4. Any questions on those 4 questions? Okay, it doesn't look like it, so I will close this. Okay, so what's next? So we'll get into today's lesson. So we'll go with the PowerPoint. Bring this up. Here's the PowerPoint. Okay, so today's lesson is on road construction or road building. So last week we looked at utilities, so that would be considered underneath the road structure. So now we're looking at above the utilities being the roads. Here's a shot of a fairly major road, so the South Fraser Perimeter Road, as it was being built. It looks like this is, looks like it's somewhere in Delta maybe. Can't picture exactly where that is. Yeah, Delta Tawasin, something like that. So what are we looking at here? So this is the existing highway. Maybe that's Highway 17. I'm not sure what that is. This is likely the perimeter road here. So there would be a structure built here. So we have some fairly deep fills, right, to bring the road grade up and over the existing road, the existing highway here. You've got on and off ramps. Again, fills have been added here. These could be potentially preload as well. For now, we'll assume they're embankment fills, just for simplicity's sakes. So building road, the new grade or new finished surface is not necessarily at the elevation as the existing surface, as we can see here. So the height of this fill is probably 7 or 8 meters high. So a lot of fill went in here in order to bring the road grade up high enough to get it across this highway here. So road building, how do we estimate road building? So similar to utilities, the first thing we do is we need layout. So the surveyors come through, do their thing. What else is included? So you'll have erosion and sediment control. You'll have some kind of traffic control. We'll have some site preparation. There's the utilities and culvert type work. We've already looked at utilities. So once your utilities are done, you will build up to grade. So with embankments, road subbase, road base, then you're surfacing, so paving, and then all the finishes. So we'll go through each of those items in detail through this PowerPoint and look at each one individually. This PowerPoint is the steps that you would take to estimate road construction. So last week's, so week 3, was the steps that you would need to follow in order to estimate utilities. So we did an example last week of the sanitary sewer. We ran through that together. So again, for this week, we'll look how road building is estimated, the various steps that you go through and take into account. So layout, again, we mentioned it last week. So a surveyor, whether it's an employee of your company or it's a subcontractor, they come through and lay out the road alignments, all the various different pieces of information. So cut depths, fill depths, where the gravels, the thickness of the gravels, all that sort of stuff is laid out by the surveyors. Again, with equipment like this, so total station type machine. You see lots of stakes with flagging like this, showing alignments, and regularly the ribbons will mean the ribbons will mean that that's the top layer of a certain scope of work. So quite often you'll see ribbons to top of subbase layer. So once you put the subbase in, then your surveyors will come back out and restake again and show you top of base layer. So it's multiple stages. The surveyors don't just come out and lay out the entire project at one go and then go away. They're constantly coming back. So erosion and sediment control. So what does it do? So it does a few different things. Prevents sediment from leaving the job site and going into the surrounding storm sewer system. So you want to prevent that from happening. So sediment in water kills fish. You can get into very big trouble for allowing that to happen on your job site. The first of which is you would be shut down. You would be not permitted to work anymore. You'd likely be possibly fined if it was a significant occurrence. So different methods of doing that. So silt fence, hay bales. We'll see a few different photos of some of these items in the next slides. This next bullet here, barricade, I guess I could touch on the first one, silt fence. So it does exactly that. It prevents silt from passing through it. It lets the water through, but it holds the silt back. Hay bales do the same type of procedure. So barricading sensitive zones. So for instance, possibly there's trees on the job site that are noted to be not cut down, so they're to be left. So typically you will be required as the contractor to build barricade type fencing around trees that have to stay. So the fencing is typically out at the drip line, so the far extent of all the branches, and it's erected so that it's a visual barrier that people and equipment should not go past that barricade, thus damaging the trees, etc. Tarps hydroseeding. So if you have piles of excavation on site, so you've excavated trenches or holes for whatever reason, and you've stockpiled all that material on site, typically you're required to cover that. So either with a tarp, or if it's a long duration, so a number of months, you're sometimes asked to hydroseed, which is a sprayed application of seed and mulch and tackifier, etc. So all those things cost money, so you need to allow for those types of things in your estimate. Possibly you may be required to excavate sediment ponds. Those are typically shown on your drawings. You don't have to come up with things like that. So you're shown how big the pond needs to be with any pipe work that comes in and out of it. So you would do a takeoff there of how much excavation you have, how much pipe, etc. Sometimes you're required to have a water treatment system. So water that's potentially leaving the job site that could be dirty, you're directed to treat that dirty water with a treatment system. So again, that equipment, so you rent it typically, again, costs money. So you want to allow for those costs in your estimate. Water truck sweeping. So if you're hauling, if you have dump trucks hauling on and off site, they're typically tracking dirt or silt and sediment onto the existing paved roads of the city that you're working in. So you have to frequently clean the roads. That doesn't mean get out the fire hose and wash all the dirt down the storm drains. That means pick it up. So street sweeping, those sweeper trucks go around and they have, those are the ones with the big brushes on the bottom that spin. So they spray a little water and suck up all the dirty solution into a tank and then dispose of it. So again, there's a cost for that. Sweep trucks are $100 to $125 an hour. So there's a definite cost there. The last one here, the CB silt sack. So that's what this is here in the photo. So this is the catch basin. There's the grate we can see. There would be a curb sitting right here. We can just see the edge of it. So this orange thing is the actual silt sack. So it has a couple of bands here to hold it in place. So dirty water would flow down the gutter line, hit the catch basin. So the water would go through, all the silt would be held in the bag. So you would be required to maintain these silt sacks on a regular basis. So what you're doing is you're cleaning the silt out so that they can continue to function. Again, you have to buy those, you have to install them. There's a cost to maintain them. So here's some photos of what we just talked about. So this is silt fence. So the black fence with the little stakes. So you pound it into the ground. You bury the bottom portion of the silt fence in the ground so that dirty water cannot flow underneath the silt fence. So this silt fence is likely protecting this stream here from, maybe this is a haul road here. So if it rains, right, dirty water would flow this way. And if the silt fence wasn't there, it would go directly into the creek and kill a bunch of fish downstream. This is the erosion control blanket. So it comes in rolls. So this prevents a slope that has no vegetation on it. So it prevents that slope from eroding in a rain event. So that's the purpose of this stuff. It's usually stapled in place, so it's held in place. It can be seeded as well, so that grass will grow out of it. There's all different types. Okay, so next slide. So traffic control is our next item. So this first bullet should say traffic management plan. So typically the word control is not here. It's a TMP, so traffic management plan. So on projects where you're working for municipalities or maybe the Ministry of Transportation, so the BC government, in other words, will require you to produce a traffic management plan, which shows in great detail all the effects on traffic that you're going to have. So whether it's lane closures, single lane alternating, anytime you need a flagger on a road, or you've got cones on a road, etc., where you're affecting traffic in one way or another, you typically need this traffic management plan. There's companies out there that produce these sorts of things. Again, there's a cost to that, so it needs to be added into your estimate. So municipal or ministry guidelines, so I did mention that. So typically ministry guidelines are more stringent or more onerous than municipal guidelines. Typically this traffic management plan needs to be engineered, so a traffic engineer needs to seal it. So apply their seal, there's a cost for that. So it shows things like where construction signage will be erected. There is a book that tells you what signs to use where, depending on what you're doing with traffic. So it gives you spacing of signs depending on the speed of the road. Obviously, the size of a sign on Highway 1 is bigger than the size of a sign on a small rural side road. Maybe that's not obvious to you, but it is. The physical size of signs is bigger. The spacing of those signs is longer. So as you can imagine, if you're traveling down the highway at maybe 90 kilometers an hour, you're going faster than you would be on a side road in the city where you're doing maybe 40 kilometers an hour. So sign spacing is important. Again, there's a book that tells you exactly how to arrange those types of things. Traffic control personnel or persons. So your TMP would physically show where traffic control people would be standing, where they're located to control traffic. Again, that same book that I mentioned, it's a ministry book talking about traffic management. It tells you where to put TCPs or traffic control personnel. Things like if you're controlling an intersection, depending on the size of the intersection, you may need more than 1 TCP. You may need 4 traffic control personnel, depending on the size of the intersection. What else do we have here? So duration and daily coverage. So do you need traffic control people only while you're working? So maybe it's an 8-hour shift. Or if we go back to the intersection example, if you have an electrical company that's working on traffic signals and they are working day and night to make the change, maybe they're swapping out old poles, putting in new ones, etc. You may need traffic control 24 hours a day. So it depends on your work hours. It'll depend on, do you have a road closure where the road is closed overnight? Maybe you need light plants to show the traveling public at night that the road is closed. So there's all sorts of things to keep in mind there. Detours. So again, if you need to close a road because you have to dig a giant hole in the middle of it for whatever reason, so the road can be closed maybe for a week, let's say. Possibly you may need to build a detour or a bypass. If you're in a city like city of Burnaby, for example, maybe there's existing streets that you can use for a detour. So you don't have to build the detour, you would just have to put signs up to show where the detour is for the public, so they know how to get around the road closure. So again, maybe you need, you know, 24 detour signs. So again, there's a cost to that. So know how you're going to build your project. If you're going to close roads, close lanes, detour traffic, what your hours per shift will be, all of that is important for traffic management. I should mention, it's not listed on the PowerPoint slide here, that project specifications will typically advise you, the estimator, how many lanes you're allowed to close. Sometimes you're not allowed to close lanes. So maybe you need to build a detour. Sometimes you're allowed to close lanes not during rush hour, so during off hours. So maybe 9 a.m. till 3 p.m. you can have a lane closure. But for rush hour, you need to have all lanes open. So it's important to read the traffic specs when you're pricing your traffic management in your estimate. So here's a photo. So this truck is possibly picking up or offloading all these traffic drums, so to be used in the future. So you can see them lined up here on the side of the road. So these are expensive. They're $100 a barrel. You can rent them, but again, if you need 200 of them, there's a cost there for sure. So here's a major route. It looks like it's a highway. So 3, 4, 5 lane highway. Looks like they have these center 2 lanes closed. So they've got these big drums all the way down both sides, so preventing traffic from coming into the closure. So same thing over on this direction of lanes. So there might be 3, 4, 500 barrels that are in place here. We don't know how long this closure is, how many kilometers it is, but that would be a significant rental cost to rent all of those barrels. If you could find them all, you may need to buy them, some of them. So site preparation was our next main bullet, back from page 1. So what does site preparation include? It includes things like clearing and grubbing. So that is not only, so clearing is cutting the trees down, pulling out brush. Grubbing is removing tree stumps from the ground. So clear and grub is removing the entire tree. So that removes the trees. So stripping is stripping the topsoil, so the growing medium that's on the surface. This can range in thickness, could be anywhere from 0, there might not be any topsoil. Typically it's 100 millimeters, 150 millimeters, can be up to 300, or depending on the area, could be 600 millimeters or more of growing medium on the surface. So you typically strip that layer off and stockpile it somewhere on site, because you typically reuse topsoil on site. You don't haul it away and get rid of it. So stripping, so after you've stripped the organics, so the topsoil off, so what's below that is your grade that you want to excavate, possibly excavate. So silt, sand, rock, any of that type of stuff. So whether you're excavating, so excavate means cut here, or filling, depends on the design of the road. So you always want to remove the stripping. That happens regardless, whether you're cutting or filling. Okay, so you remove the stripping layer off, and then depending on the design for the road that you're constructing, you would either cut down to the subgrade, or you would fill up to the subgrade. So subgrade meaning the bottom of subbase gravels. Please make a note of that if you do not know what subgrade is, or grade, it's also referred to as. So this bullet here, typically engineers try to balance the cuts and fills. So, I mean, that's the idea. On, I wouldn't say most, but on some projects, you can, whatever excavation you use, you can put that into a fill if it's approved material. So typically the BC government or Ministry of Transportation allows you, the contractor, to do that. So cuts can be hauled into fills. So you don't have to dispose of all your cut material off site. So it saves the project money. And then you don't have to buy as much imported fill either. So there's kind of a double savings there. That's why the engineers try to balance these two numbers. So if the amount of cut is basically the same as the amount of fill, then the cut can go into the fill. You don't need to dispose of anything off site, and you don't need to purchase any imported fill. That's kind of the idea behind that. You're only allowed to do that, so move the cuts into the fills, if the specs tell you to do that. Don't assume that you can do that. That could be a very costly mistake. Pardeep, what is a subgrade? So again, the subgrade is the bottom of the sub-base gravels layer. So let me get out of the PowerPoint and flip back to my scratch pad here. So I'm going to draw a typical section. So we could have, so this is a cross section of a road. So we have a lane going this way and a lane coming this way. So we've got a center divider there somewhere. So the top layer is typically asphalt, right? So we have an asphalt layer here. So asphalt. below that is your first gravel layer. This is the road base. Usually it's 19 millimeter. That's the size of the gravel. And then you've got, typically it's a thicker layer than the base. So I'll draw it with a slightly different hatch on it. This would be the road sub base. Again, this is gravel. This is typically a 75 millimeter and smaller size gravel. It's usually thicker. So this thickness, this depth is usually thicker than this one, than this depth. So this one may be 500 millimeters. This one might be 200. Something like that. So again, this is the subbase layer. So the bottom of the subbase, so right here, is your subgrade, or grade, it's also referred to as. So this stuff here, if this layer here, if this surface here was our original ground surface, so that's what it was before we started working on the job site, that was the height of the existing ground, we would say this was a fill. So we had to fill up we're filling from original grade up to the subgrade. You would, I guess for completeness, you would strip a section here first. So strip this first. So then your fill depth is now, it's no longer from the original ground surface, it's from your strip surface. So the bottom of your stripping up to the bottom of your subbase, which is subgrade. Does that make sense? So this would be a fill section. If we, if I do a cut section, I'll show you what that looks like, or an example of what it could look like. So the same sort of prison here, right? So asphalt base, maybe this whole layer is subbase. There's the subbase. This was the base. So base. This is subbase. So in a cut, this one was fill, we said. So in a cut situation, let me grab a different pen here. The original ground isn't down here somewhere. The original ground maybe is here. So meaning original ground. So from the original ground, we need to excavate in order to get to the subgrade. So again, bottom of subbase layer is subgrade or grade. So again, we could, flipping back here, we stripped before we started building fills. So you would do the same thing with a cut. you would, now you couldn't just strip this piece, right? Because our sub base has to go way out to here. So we likely couldn't even strip out to here. There's going to be a slope here. So we would have to strip out to this edge way out here. So that is stripped. So then the cut is from the bottom of the stripping layer, the cut depth is from the bottom of the stripping layer down to the bottom of our sub base or subgrade. So that's the difference between a cut section here and a fill section here. Okay, let me go back to the PowerPoint. What materials used for subgrade? So this is where, when I mentioned that the Ministry of Transportation sometimes allows cut material to be placed into a fill. This is where the subgrade is built with fills. So it could be excavated material from elsewhere on the job site is subgrade material. So that's what you're building the subgrade out of. Or on other projects, like for municipal projects, so you're working for a city, they require you to purchase gravel and place it as either subgrade fill. It's also referred to as embankment fill. So you're building embankments. Again, it will tell you, contract will tell you in the specifications what materials you're allowed to use where. So it'll tell you what kind of gravel to use for your road base. It'll tell you what kind of gravel you need to use for sub base. It will tell you what to use for subgrade fills. Okay, same thing on this section. Let me bring up the PowerPoint again. Okay, we seem to have skipped back to the beginning, so I'll skip ahead. Okay, we got to here. So stripping, so we just talked about excavating to grade. So preload is the next bullet there. So what's the purpose of preload? So you preload a road surface, or a future road surface, I should say, in order to squeeze the water out from down below. So the geotechnical engineers on a project will know that there's soft material, soft, wet material that's deep down underneath where the road's going to be built. They sometimes require you, the contractor, to preload this area. So they will tell you to build embankments. So you're placing fill. It's typically sand, a certain number of meters high. So it could be 3 meters, could be 5 meters high, across the entire road footprint. So full width of the road times the full length of the road at the height that you're directed to. So that material stays there. So it's of course heavy. It squeezes the moisture or the water out from down below, and it will also settle. As the water is squeezed out, the road will settle. So the preload is allowed to stay there for a number of months. Usually, it's usually 6 months or a year. So after all the settlement has occurred, you're then allowed to, as the contractor, to remove all the preload sand. So remove that 3 meter or 5 meter high fill, get rid of it, take it off site, and then you're allowed to build the road. So that's when you would proceed with your either cutting to subgrade or your filling to subgrade, and then road structure from there, subbase, base, pavement. So the preloading allows settlement to occur so that after you've built the road theoretically will not settle, or very little, if at all, is the purpose of preload. So bullet there, duration and volume depends on soil conditions. Again, you're told how much to preload. So the volume of material, so the length, the width, the height, you're told. The type of material to use, you're told. So the last one there, sequencing work strategy. So again, if there's a preload shown on your tender drawings that you're looking at, once you place the preload, you can't build anything there until the preload's removed. So you may have to wait, like I say, 3 months, 6 months, a year in order to start to build the permanent road structure in that area. So you need to keep those kinds of things in mind. So you're sequencing the work. Again, it's directed by the engineer. So it'll be shown on the drawings to preload if preload is required. There would be a separate bid item for it too, typically. So it's not hidden. If it's there, you'll see it. It'll be obvious. So photo on the left is a clearing and grubbing operation. So you've got an excavator, looks like it's piling up stumps to be hauled off. So removed from the job site, disposed of. The dozer on the right is scraping off the organics. So that dozer is stripping the topsoil. So it's pushing it off to the side. Again, to be reused later on the project. So site prep continued. So photo on the left. So this setup here is excavating to grade. Now, look at the size of this equipment. There's a person standing there. That's a pretty big rock truck or articulated truck. Looks like it's a 40-ton. Quite a large excavator as well. So there you can see the original ground surface is up here underneath the truck, and they are digging way down to here. That could be 3 meters or more deep that they're digging to get to the subgrade. Not sure what this is here. So photo on the right is preload. So all this sand up here, that's the preload. So it's being stacked up high. This preload could be 5 or 6 meters high. So the gravel trucks, so truck and transfers, bring in hundreds of loads of preload. So dump it, and then the excavators and dozers build the preload per the design. So operations like this, where you have loaded gravel trucks, even empty gravel trucks traveling on sand, is it's difficult for trucks, whether they're loaded or not, to get through, to drive through sand. So it has to be watered and compacted on a regular basis. I just went through the preload make. You'll have to go back through the video and look at it. I talked about it for 5 minutes. So a preload operation could be quite time consuming. Preloads can be tens of thousands of cubic meters of material being placed. So they're usually quite expensive. So utilities and drainage is our next major bullet. So we talked about utilities last week. So things like, let me just back up a second here. So at this point, we've excavated to grade. Maybe we preloaded. The preload's done now, where we remove the preload. Then we excavate to grade, right? So we're cutting from the original ground surface after we've stripped. And so we're cutting down to subgrade. So at that point is typically when you want to do your utilities. It simply allows for shallower trench depth. So it's helpful that way. It costs you, the contractor, less if you don't need to dig trenches as deep. So utilities, things like water, gas, communications, storm sanitary, street lighting, road drainage, so your catch basin leads, your storm mains. So culverts would go in, head walls. So a head wall is at the end of a culvert. Other things like ditches. So on the side of a road, if there's no curb on the sides of the road, you typically have ditches. So the water on the road sheds off the road and goes into the ditches. Maybe there's some settlement ponds, that type of thing. Again, all of that is shown on the drawings. So it's not up to you as the estimator to design all this stuff. You just need to know that you have to do your takeoffs and how to price it. It'll all be shown for you on the drawings. So a couple more photos. So looks like street lighting photo on the left. So we've got a ditch here, some ditching. There's some silt fence. There might even be some straw bales in there. So we've got some traffic cones. Photo on the right, some culverts. So this looks like a highway. Before the highway road structure was built, so meaning the sub-base gravels, the base gravels, the paving. Before that, these culverts would have been put in. So trenches would have been cut across the highway, and these would have been installed in sections, backfilled, and then the road structure would be put on. Okay, so we've installed our utilities. Now our next major bullet is building to grade. So we've backfilled our utilities up to, say, subgrade is pretty standard. So again, subgrade is bottom of sub-base gravels. So building to grade. So you can possibly use existing materials. Again, it's for road sub-base and road base, it's unlikely you can reuse existing material for that. 99 times out of 100, you're buying new stuff. So you're importing gravels is what you're doing. So you're bringing in new stuff. So import. You're raising, if your subgrade needs to be higher, you're raising the grade with fills. So you can import that, or I guess that's the existing materials that they're talking about here. Can be your subgrade. I will scan and post the two typical cross sections that I sketched up on the notepad. I'll post those onto the news feed as well. Maybe at the break I'll do that. So we're importing gravels, so you need to compact those gravels. So we're compacting the sub-base first. So gravel gets hauled from a quarry somewhere, hauled to site in truck and transfers typically. So the trucks dump it on the ground. Then you need to spread that gravel. So different companies use different methods, whether it's a dozer or a grader. Once it's spread out, it's then compacted. So with a vibratory roller is the most common. You also need water. Gravel needs to be at a certain moisture content in order to be compacted correctly. So typically you need to apply water to the gravels. Now, if you're building a road in Vancouver, or the Lower Mainland, I should say, in the winter, you typically don't need a water truck because it rains every day. So there's a comment here, testing by who, or whom. So who will test the level of compaction that you've applied to the gravels? Typically, it's the contractor that does that testing. So again, there's a cost to that testing. So certain number of tests. So the QC testing company comes out with their equipment, does the density testing for you, gives you reports showing what is compacted adequately and what needs more compaction. So then you do the same type of operation for the base course. So you just built sub-base gravels, now you're building base gravels. So it's basically identical to above, same procedure. So it's hauled from a quarry, it's dumped, the dozer or the grader spread it out, it's compacted and watered and tested. Here's a photo on the left. So there's the 75 millimeter minus gravel. So it's being dumped there with the dump truck, and then the dozer is pushing it out, so leveling it out. The photo on the right is another dozer. It's grading the side slope of the road. So the top of the road surface would be over here. Maybe it's up here somewhere, and then there's a slope here, slope down. So the dozer is over there making that slope smooth. So there's photo on the left is a grader, so grading out the road base. So that's the top layer of gravels, so leveling that out. Here's a compactor going back and forth on the gravel, getting compaction. So then at this point, we've placed and compacted the sub-base gravels and the base gravels. So what's next to go above that? Typically, it's the next major bullet. It's the road surface. So typically, it's asphalt. So before you put the asphalt down, if the road requires curbs, curb goes in first. So concrete curbs. Oops. So if the surface is not paved, then that's the end of it. So you could have a gravel surface. You could have what's called an asphalt millings. So what is that? Asphalt millings are ground up asphalt. So there's machines that go around that have big teeth underneath them on a big wheel, and they dig into the pavement, and the wheel is spinning, and it grinds up the pavement that's there into small pieces of pavement that are approximately 19 millimeter and smaller. Those are called millings. That's also an optional road surface material. Of course, it's not used in cities. Maybe it's used for driveways, gravel pits, that sort of thing. Asphalt here, most common, it says. So asphalt would go on top of the road base. So it says it's staged. Typically, there's two usually 2 layers of asphalt. There's a base lift of asphalt and then a top lift of asphalt. Usually the base is applied, of course, first, but it's left as the first layer only until all construction is completed. The top lift of pavement is only applied usually a couple months after everything's done to make sure that the top surface will not be damaged in any way. So another option for road surfacing is concrete here. So not really used at all in BC. You see a lot of concrete highways in the United States. Another option, again, very rare, is stone pavers. So like bricks. They can be used, you might see them at maybe Stanley Park as a pedestrian crossing, you know, crossing a road. They might use pavers to make it look, you know, fancy and neat. Typically, we don't build roads out of pavers, stone pavers. So the photo on the left is, so this is a highway in, well, it's out of a, it's not in a city. Obviously there's, you know, trees and bush surrounding it. So what this whole setup is doing is it's grinding up the existing asphalt. It's heating it up to a certain temperature. It's applying additives to that hot ground up asphalt, and then out the back it's paved. So what this whole train of equipment is doing is removing some of the existing pavement surface, grinding it up, adding some additives, and then reapplying that same asphalt down. So you're basically repaving the highway using the existing asphalt. Pretty neat setup. So the photo on the right is just a straight paving. So the asphalt is brought in, it's loaded into the paving machine, and it's extruded out the back to a certain width. 2 paving machines here. So they're doing, looks like possibly the full width of the road in one pull. So 2 paving machines side by side, rather than, you know, doing a lane width, you know, for 3 kilometers and then circling back and coming and doing the other lane width and doing that whole length. It's quicker to have 2 pavers. So after the road topping, or the road surface, I should say, is the finishes on the road. So things like line paint needs to be applied. So all permanent line paint is shown on your drawings. So every lineal meter of paint will be shown, so you can do an accurate takeoff. You'll be told the width of each line, and then you can scale for the length. Other things like street lighting. So you've previously installed the street light conduit in the road shoulder. So, and all the bases, so the big concrete bases that the street lights will stand on. So those are already in the ground. At this point, the electrical contractor comes in and stands the street lights. So they come in with the poles, bolt them to the bases, and that's basically it. I guess later they'll pull the cable through and connect everything. So other things like street signs are installed at this point. So whether it's stop signs, yield signs, no parking signs, all the different permanent signs are installed at this point. The big overhead type signs, so the ones that you see on the highways that sometimes are hung over top of the road. Bases for lights are installed when you're doing your utilities, so the conduits. So it really depends on the alignment. Yeah, so it's done before paving. Typically, the conduits go in behind curb, so it's done before then. So the bases are there already. Yes, so a street light base can be 1.5 meters tall. So you typically only see the top 50 millimeters of it sticking out of the ground, but there's another 1.5 meters that's buried. Sometimes more, depending on the size of the sign or the street light. They're quite large, concrete bases. Street signs, so the next one here, no post barriers. So that's what these are. So this looks like Eagle West installing barriers across. That could be the new Port Man, possibly. Hard to tell what it is. Might be the Port Man or the Alex Fraser, I guess. So those are linked together, usually down the shoulders, for the most part. Different sizes of barriers are used in different places. So there's a roadside barrier. There's a median barrier. Line paint is usually 100 millimeters wide for like a white line down the road or a yellow line. Typically 100 millimeters. Usually the only time they're wider than that is for like a stop bar. So the real wide line that's at an intersection where your cars are meant to stop. Those are typically 600 millimeters wide. So the last one here, landscaping. Again, at this point, you could do your topsoiling, your sodding, spray your Hydroseed. Typically, erosion blankets are done before this. Maybe trees that you need to plant can be done then. So the photo on the left is a Hydroseed equipment. So there's a truck pulling a trailer. So this is a small Hydroseed unit. So it's a person. So there's a tank on here with a pressurized hose. So it's pumped out and it's blown almost like a fire hose onto the ground. So it looks like green paint to the untrained eye, but it's a mixture of seed, fertilizer, tackifier to hold it there. So it's a blend of all that. So Hydroseed will grow on anything. So you could spray it on pavement and it'll grow grass. Of course, it won't survive there. There's no soil there to keep it alive, but it'll start to grow on anything. So it's easy to spray it. So from the road here, you could do this whole bank in a relatively short amount of time, and it's cheap. Hydroseed is typically for a really big area, so we're talking about thousands of square meters. It's less than $1 a square meter for Hydroseed. So the photo on the right here, so we have some street lights. So there's all the street lights. So we've got paint. So you have fog lines or shoulder line here. So you've got a dash line. You've got double solid yellows in the middle, another dash, another fog. So you've got arrows, right, that need to be painted. All that stuff will be shown on your drawings, so you can take it off, do your takeoff. So trees down the boulevards. Looks like maybe there's a big sign here hanging over the road. So this photo here shows you, again, typical cross section, shows us a typical section that has a cut component as well as a fill component. So this squiggly line here is the original ground surface. So maybe this is on the side of a hill or the side of a mountain. So the engineer wants to build a road. So here's the center line of the road. So they've located it here. So these various lines here are, so your asphalt is on the top, then your base gravel and your sub-base gravel, right? For my notes that I did on my scratch pad. Everything below that is your embankment fill, also called subgrade fill. So all of this here is subgrade fill. Everything in where my mouse is. So then on the uphill side, if we need the edge of the road to be here, we need a ditch. So that'll be shown on the drawings. So we'll cut in a ditch, and then we can't cut this vertical, right? Because as soon as it rains, that whole bank will fall on the road. So the engineer will design this back slope, will tell you how steep that can be. So they'll show a line out here. So then that means all of this material needs to be excavated out of there. So from the original ground surface to this cut slope here, or this back slope as it's called. So including the excavation for the ditch. So what else can we see here? Again, similarly, edge of our actual paved surface is here somewhere, right? We can't just build a fill that's vertical. We need a fill slope. So that when it rains, this slope doesn't just erode and wash down the hill, and then the whole road is eventually eroded away. So you always have these slopes here. They range from 1-to-1 to 2-to-1, 3-to-1. So the higher the number, the flatter it is. This looks like a 1-to-1, I would say. So meaning 1 horizontal to 1 vertical. That's what 1-to-1 is. 2-to-1 would be 2 horizontal to 1 vertical. What else can we see here? So this is the roadway width. So from the top of that cut to the toe of that fill, this is called the toe. So the bottom of a fill, the limit of the fill is called the toe. So the clearing width, this would be again shown on the drawings. You'd be told how far to clear. So the limits would be given. So you wouldn't leave a tree right here, right at the top of the cut slope, because that could easily come down in a rain. You would be, if you're cutting here, you're likely cutting through the roots of that tree. So you clear back a certain distance, so you're not damaging any roots. Same thing on the fill end, the fill side. You don't leave a tree right here. You don't leave a tree right next to a fill. So gravel is heavy. So putting something heavy onto tree roots will likely kill the tree. And then the right of way of the road. So typically the road right of way, so in between this line and this line, is owned by the government. So whether it's a municipality or the BC government. In behind that can be private property. It may also be provincially owned if it's in the bush somewhere. So let's talk a little bit more about cuts and fills. So a road alignment will probably have both cuts and fills. I would say almost without a doubt it will. Even if it's just stripping, if all the cut you're doing is stripping, it's still a cut. You're still excavating something. So cut is the in situ earth that needs to be excavated to achieve grade. So I believe I showed that on my typical cross sections that I sketched up. Again, I'll post those for you to download. So that material, that cut material, may be reusable, or it may need to be hauled away as waste or spoil. This is also referred to as bank material. So it's bank in place. It has varying levels of compaction. So existing material is compacted to some amount. So that's cut. So fill is material necessary, again, to achieve grade. So you're filling up to the subgrade level or bottom of subbase. So that's the same spot. It could come from cut, or it can be imported material. Again, subgrade fill can be existing excavated material. It could be imported gravel. Again, this fill is compacted. So every time you place fill, whether it's embankment fill, subbase gravel, base gravels, it always has to be compacted. I guess I should clarify, that's in a traveled roadway. If you're backfilling something that is never going to be driven on, maybe you don't have to compact it, with a compactor. Maybe it's just the backside of the bucket of the excavator. So as you dump it in, you kind of push on that filled material with the back of the bucket. It's called a bucket pack. So compaction, so every material has a different, this shouldn't say maximum. Well, I guess that's true. Every material has a different maximum compacted density, not really weight. These are densities, kilograms per cubic meter. So 1,600 for earth, so silts and clays. 2,300 for gravels, aggregate. So gravels are typically sold by the ton, but you install them by the cubic meter. So your estimate, you're going to place 500 cubic meters of gravel. So your crew is placing, 50 cubic meters per hour, but you're going to buy 1,000 tons of that same gravel. So you purchase it by the ton and you place it by the cubic meter. The accurate conversion for installed compacted material is best used for estimating, right? So typically with road base and road subbase, the specified compaction is usually works out to a density of approximately 2,200 kilograms to 2,300 kilograms per cubic meter. So that's the conversion that you want to use. So if you need 10 cubic meters of gravel, you multiply 10 times 2.3 tons per cubic meter to find out how many tons of gravel you need to buy. So placement is based on achieving compaction. So your crew, again, would need some type of compaction equipment. So this photo down here is a quality control technician. So they're using a nuclear densometer. That's what this machine is. What the technician does is this plate rod is pounded into the ground with the sledge. The rod is then removed. The plate is left there, so you don't move the plate. This machine is then placed over top, and the operator, by pushing down on this handle, inserts a probe into the hole that you've just pounded into the ground. And by, so it's, the reason it's called a nuclear densometer is it has radioactive material in it. So it calculates the density of the material that it's in by the time that it takes for a signal to go from one spot to the next. So that is a machine that measures density. So next page here. Okay, so I'll quickly touch on, there's a couple slides here of tenders. We'll go through these 2 slides and then we'll have our break. And then I'll go more in depth into what a standard tender document looks like. We'll kind of get a brief overview on these next 2 slides, and then we'll go into detail after the break. So submitting a tender is your offer, so you being the contractor, your offer to complete a scope of work for a certain dollar amount, for a certain value. Typically 3 types of tenders. So there's a lump sum tender, there's a unit price, and there's a time and materials. So these are the 2 most common types of tenders, lump sum and unit price. So lump sum means it's up to you, the estimator, to determine the quantities of everything. You have to look through the drawings. You have to come up with everything from the amount of stripping that you have to do, the amount of excavation, the amount of curb, the amount of asphalt, the amount of street lights, all that stuff. You have to do a takeoff and count everything. Assignment on tenders. No, I don't believe there is. So that's what a lump sum tender is. So the other type, the most commonly used type, is unit price tender. So in a unit price, you're given estimated quantities for everything that's shown on the drawings. So you're given estimated quantities for the amount of excavation that there is, the amount of curb, the amount of base gravel, the amount of asphalt, etc. So you're given quantities for everything. It's good practice to check to make sure those quantities are correct. So this bullet here, so when you submit your tender and you provide unit pricing and a total at the bottom, the values that you've entered are what's referred to as binding. So you can't, after the fact, change your tender. So if it's a unit price tender, and say when you bid the tender, there was a quantity of 500 cubic meters for road base. So you bid the 500 cubic meters per the tender. So you get the job and you start to build the project. And at that point, if it's determined that that estimated 500 cubic meters of road base is wrong, maybe it's 1,000 cubic meters. At that point, once the bid quantities change by plus or minus 15%, then you can start to change your unit pricing, but not until then. So the last type of tender is a time and materials. It's hourly work. So you provide hourly rates for your crew and equipment. So you've got a grademan rate, a foreman rate, pipe layer, equipment operator, etc. You provide all those hourly rates. You provide rates for your equipment, and then you invoice for hours that are used based on your hourly unit prices that you've submitted. So that's what time and materials is. So time being you invoice for the amount of hours that you use. Materials, meaning if you've purchased any materials, you're allowed to mark up that cost. Typically it's 10%. And so you're paid back the cost of the material plus a 10% profit amount. Again, this one isn't common. As far as tenders go, these are the most common for tenders. So this could be a typical tender schedule of prices. We'll get into this in more detail after the break, but you have all these, so all the tender items are numbered. So you've got a column telling you what spec to refer to. So in the spec 1.1, you would be told what exactly excavation and disposal is comprised of, what costs you should include for this item. Also, for example, this one here, this 1.4.2 would tell you the type of granular fill that you would be allowed to use. So this would typically be a subgrade fill item. Where it says granular fill, that's usually embankment fill, or subgrade fill as it's also called. So meaning that's different than road base and road subbase. Excuse me. Other items here, some storm sewer, etc. Again, we'll take a closer look at that after the break. So the last page, understand the pay quantities and bid to them. Okay, so it is, stop that share. What time is it? So it's 8:20. Let's take a 10-minute break. We will come back at 8:30 and have a closer look at a typical tender package. And then that's all the instruction I'll have. Then I'll hand out the exercise for this week. Actually, I'll post it now to the news feed. So we'll meet back here at 8:30. I'll pause the video recording. Okay, so I posted this week's assignment. I'll talk about it after we look at the tender, typical tender. I also posted the 2 pages of the typical cut and fill cross sections. So that's also on the news feed. Okay. Tender. So I'll share my screen. So this is a typical tender. So it's actually fairly small. It's only 87 pages. So this project is shoreline stabilization and a deck replacement. The owner is the City of North Vancouver, and ISL is the engineer. So we're not going to look at all 87 pages, of course. I just want to highlight a few different sections to you so that once you get one of these thrown on your desk, when you first start estimating, you'll kind of know what you're looking at, where to find things, etc. So clicking through the pages, table of contents. So this is the invitation to tender. So it shows things like who the owner is, what the official name of the contract is. It gives a kind of a general scope of work here. It tells you that the tender documents can be downloaded off of this website. So that's a typical place to find tendering information or tender documents is BC Bid. Tells you, this line here tells you that there's a mandatory, notice it says mandatory, bidders meeting on such and such date. So the importance of that is if it says a mandatory bidders meeting, that means if you want to bid the project, so submit a tender for that project, you have to show up at the meeting. Under no circumstances can you miss that meeting. If you miss the meeting, they will not accept your tender. So that's important. Only if it says mandatory meeting. Quite often it says optional meeting. So down at the bottom here, so it gives you other information. So the time that the tender is going to close. So 2 p.m. on the date. So take that as written in stone. If you submit your tender at 2:02 p.m. on Wednesday, December 11th, they will not accept it. If you submit it at 2 p.m., exactly 2 p.m., they will not accept it. That means at 2 p.m., the tender is closed. You have to submit your tender in an envelope prior to the closing time. So I can't stress to you how important that is. You may end up working for 2 weeks on a tender, coming up with your estimate and finalizing everything and writing it all up. So two full weeks of your time. If you show up late and try to submit it late, they won't accept it. It'll be 2 weeks of a complete waste of your time and your boss's money paying you to do something that you weren't able to submit. So that, to me, that is the most important part of a tender, is when it closes. You have to know that. Of course, things like give yourself lots of time to get to the location where it's going to close. So that's what's next here, is you're told exactly where to bring your tender. What else do we have here? Instructions. Other thing I should say as we're going through this 87 pages, you should read every word that's in this tender document. Do not skip anything. You run the risk of, if you don't read everything, you run the risk of not knowing something that you may need to know. And it could cost you or your employer, your boss, either a little money or a lot of money. So I won't go into all the details of that. That's its own 3-hour class. So what to take out of that comment is read every word that's in the tender document. So instructions. So at this section, so form of tender. This is what you actually submit in your envelope at the closing location, closing time. So the form of tender, this one is 16 pages long. This is what it looks like typically. It's got the owner, the contract again. There's a section for addenda. So if you don't know what an addendum is, it's a change to the tender documents. So maybe it's a new drawing, maybe it's an updated drawing, maybe it's a change to some of the specs, maybe it's new additional specs. Those all come out as addendums. So they're numbered sequentially. Of course, the first one's number 1, number 2 is the second, and so on. So this is where you would list any addenda that you've received for the project. Again, if there are 3 addenda that have been issued and you skip this step, you run the risk of having your tender thrown out. Even if you're the low bidder, you may not be awarded the project because you didn't fill out this section. This is another important section. Skip down a little further here. You're typically always given a date of when the job must be completed. So I highlight this because after you've completed your estimate, so you're done your costs analysis, you should do a quickie schedule, so a real rough schedule, see how long you think it's going to take to build the project based on the productions of all the different scopes of work that you've built into your tender. So if you think it's going to take you 6 months to build the project, but the completion date for the project is only 4 months, then there's an issue there. So that sort of information you should tell your manager or whoever you're going to answer to, being a junior estimator. There's different things that you should do if you run into that problem. I won't go into them now. If you're curious, you can send me an email and I'll tell you. But we'll run out of time today if I get into that. So skip ahead here. So we're still in the form of tender, page 2, page 3. This is where you write in your company's name and address and you sign it. And so here is where all of your hard work goes into. So this is the summary page of the costs for your tender. So summary numbers go in here. On this page, I'll point out that GST is shown separately. I mentioned previously that when you're compiling your estimate, when you purchase materials in your estimate, you include PST on those materials in your estimate. So what does that look like? So here's a detailed page of the first page of all the tender quantities. So we look at things like excavation and disposal, tender quantities 390 cubic meters, right? Excavate and reuse on site, the tender quantity is 910 cubic meters, so et cetera, all the way down. Here's a good example. So granular fill, so that's your subgrade fills, right? Imported, so you're purchasing gravel here, 10,770 ton. So inside this bid item, when you cost this bid item out, you're going to add 7% to the purchase price of all of this gravel. So your PST cost is going to go in here. You would do that for all of these bid items. Whenever you're buying materials, you will add PST and include it in your individual bid items. These are bid items here. This row here, that's one bid item. So excavation and disposal is a bid item. Excavate and reuse is another bid item. So PST goes in here. So we flip back to the previous page, go down to the bottom. So these are the summaries of all the sections. So all these numbers here are going to have PST in them. Down here is where you show GST. So GST is 5%. GST applies to every cost that's in your tender. So you'll add up all these subtotals, get a tender price subtotal here. Maybe say it's $1 million. On this row here, you'll show 5% GST. So your calculation is 0.05 times whatever number this is. So 1 million times 0.05. So that's $50,000. So for this $1 million tender price, you've got 50,000 of GST. So your total tender price is the sum of those two. So your total tender price for this example is $1,050,000. Okay, so that was GST. So let's take a little bit closer look here. So again, I mentioned in the PowerPoint before the break, so you've got item numbers. So this is just sequential numbering of all the bid items. So there's no confusion. They're all numbered individually. The next column here shows the relevant specification that applies to each individual bid item. That's what that column is. Here's the description of the bid item, this column. So we've got things like manholes. So a 1,500 diameter manhole. It's a lump sum, it says. What else do we have here? So we've got a demo line item. So demolition of existing platforms. So this is the heading for this section. So we're demoing concrete and timber. Here's steel piles. So you got a mob for the pile of crew. You got a supply of the steel piles, and then you have an installation of those piles. So those are all your descriptions for the bid items. These are the units that they're each measured by. So whether it's a lump sum, cubic meter for volume, tons, for typically that's gravel, could be paving. Here's a length, so meters of pipe, more lump sums. Here's an each. So there's 86 pipe piles that are to be driven into the ground. So you price each one of them. What else do we have here? Kilos. So this is optional work. Tons. So optional meaning it may or may not be included in the project once it starts. So that gives the owner, so in this case, the city of North Vancouver, they have the option to delete any bid item that's labeled as optional without compensating you whatsoever for it. So you should be aware of that. All sorts of excavation of contaminated materials. That's what all these are. Okay, I won't go too much further through this tender page here. So this is what a typical tender page looks like. So your schedule of quantities. I guess we didn't finish the columns. So quantities is the next column. So the estimated quantity. So a lump sum is a quantity of 1 or 100%. So this is where you fill in. So you, the estimator, determine what your unit price and what the total extended amount is for each bid item. So typically companies use some type of software. You don't have to though. It just makes it quicker. When you're completing your estimate. So the way this works is you'll come up with a unit price. You'll take this unit price, multiply it by the tender quantity, and that's your total amount. Bruno, what does SS? Oh, this here. So SS is Supplementary Specification, and it's a reference. So it's telling you where in the specs to find all these different clause numbers. Sometimes you'll be referred to a supplementary specification, which is specific to this project. So it would be included in this tender package. Other times you're referenced to the Master Municipal Construction Document, or MMCD. that book is not included in this document. So you have to, your company has to own that book in order for you to look at it. So it's typically 2 different places to look for specifications. In the MMCD, which is a separate book, or inside the tender package, which has a whole bunch of project specific specs. So you're simply multiplying your unit price times the tender quantity to get the total. So you do that all the way along here and total as you go. So after all the schedule of quantities, so notice we are still in the form of tender. We're on page 8 now. There's typically this page. This is your rough schedule. So you're obligated to provide the owner with your best guess at a schedule. They want to see that you can complete the job in the time frame that they've given you. So you need to complete that schedule. So the next page is where you provide your experience of your superintendent. So typically what I do is I just provide a printout of my superintendent's resume. I don't fill this out every time. I just insert a page of their resume. Similar work experience. So of course it's, or comparable work experience. So you want to provide projects that are similar to the scope of the job that you're bidding, so that the owner can see that you have experience building these types of jobs. Your list of subcontractors that you've carried in your tender. So if you are intending on subbing out the paving, you would want to list your paving subcontractor here. So under trade, you would say asphalt, and subcontractor name, you would say, you know, like BA Blacktop or something like that. This is not standard. I won't mention that. This is not standard. That's not standard. They sometimes ask you where your dump site is, so your spoil site. So any excavation that you need to haul off site, they want to know where you're going to bring it. So usually for the sole purpose of ensuring that that dump site is permitted. So they purchased a permit and have been authorized by the city to take spoil material on that land. So that actually is page 16. So that's the final page of the tender. So it's only those 16 pages that you would submit. For me, I would insert also the resume of my superintendent. So I would have a 17-page tender. There's typically other things that you submit, stuff like bonds. That's more contract law. I won't get into it too much, but it's a piece of paper, so it would be submitted with your tender. So I will skip ahead. So here's your supplementary specifications. So that was that SS reference that you mentioned, Bruno. So supplementary specs. So it's included with the contract document. So the MMCD is the other book. So Master Municipal Construction Document. So every contractor owns one, I guarantee it. So if you go to work for a contractor, they'll have one. So I'll show you what this supplementary specs looks like. The numbering system in supplementary specs is the same as the MMCD. So this was the old version, this numbering system. It was called the Gold Book of the MMCD. So 02223 was excavating, trenching, and backfilling. Aggregates is 2226, riprap 2271, right? Storm sewers, manholes, etc. So let's see what a couple of those look like. So there's some general information. I can post this as well to the news feed to give you a chance to look at it in more depth. So here you're told materials testing. So you're told testing is by the contractor, so you need to allow costs for quality control testing, so density testing, testing of concrete. Skipping through here. So here's a traffic section. It's short. So what this tells you is you need to reference the MMCD document, so that other book that I mentioned, and you also need to read this page. You need to read them together. This does not tell you everything about traffic control. It only tells you things that the City of North Vancouver has changed for this project. Everything else that's in the MMCD also applies. Record documents. So here is the excavating, trenching, and backfilling supplementary spec. So it gives you a general. So it tells you this is to be used for installation of a retaining wall and grade beams in accordance with MMCD. Excavation of contaminated material, you're supposed to follow the geotechnical's direction, geotechnical engineer's direction. Tells you how excavation will be paid, how it's going to be measured and paid. So payment for excavation of material for reuse on the project will be made at the unit price bid per cubic meter as described in the MMCD and the rest of this project. So payment for this item includes excavation, any stockpiling that you need to do, replacement, watering, and testing. It should say compaction there also. They missed compaction. So it tells you how to place. So it gives you, each of these sections will give you details on how the bid items are measured, how you will be paid, what to include, specifically what to include. If we skip ahead to a gravel, aggregates, yeah, so this one doesn't tell you what type of gravel to use. So that means you would have to refer to the MMCD on, for example, the subgrade fill, that 10,000 tons that showed up in the schedule of quantities. Doesn't tell you in the supplementary specs what type of gravel to use. So then you would fall back on the MMCD and see what that says. So riprap, here's storm sewers, tells you type of pipe to use. That's what all these details are. Manholes. So all the different bid items are detailed here in the specs. You should never need to guess on what model of or what type of material to supply. You should be told. If it's not listed in the specs, then you need to ask the question. So you can ask the engineer questions during the tendering process. So scrolling through all the specs. This is only a short general conditions from the MMCD. So this is only a short few pages that they've copied out of the MMCD and inserted here. The MMCD is about 2 to 3 inches thick, so it's a relatively thick book. It's probably 300 or 400 pages. And typically with your tender package, you will be given a set of drawings. So here's the drawings that are associated with this project. So they're all in here. Okay. So again, if you're interested, I will post this sample tender package to the newsfeed, so you can download that and take a closer look at it. I'll write myself a note here. Okay, so then lastly is the assignment for this week. I'll quickly talk about it. Okay, so assignment is right here. Okay, so here's the assignment, what it looks like. So question 1 worth 4 marks. Complete the average end area calculation for the access road. So what's the total cut and fill volume for the access road? So I believe I posted this document onto the news feed. Let me go back there and take a look. So exercise road building. Yes, so I posted the average area template. So it's an Excel spreadsheet. It's in the week 4 handouts, newsfeed item. So what does that look like? I'll bring up the Excel spreadsheet of what that looks like. This is what you'll download off of the newsfeed. So it is this. So this is what it looks like. So what this allows you to do is do a calculation of the end area for each cross section of the access road. So let me bring up the access road drawing so you know what I'm referring to. It is, here it is. Okay. These are the cross sections for the access road that you have in your drawings package. So this is sheet 8 of 10 in the PDF. So let's look at this one. So I'm looking at station 0 plus 110. So this should look relatively familiar or similar to the typical fill cross section that I drew up earlier in class. So I drew it in red. Again, I posted that to the news feed. So what do you do here? So what the first question is asking you is to determine how much fill is required to build the access road and how much cut or excavation is required to build the access road. So what you will do is go to each cross section. So they're all listed here on this page. So you'll go to each one and calculate how much cut and how much fill is in each cross section. So you'll need to scale this. So what you're measuring is, I should have brought this up as my other PDF. Maybe I'll just use my mouse. So what you're measuring on this particular cross section, okay, this rectangle is the road structure. So that's, I think that's road base. So that's not included in your calculation. You're looking at the volume or the area from this solid line. You'll come up, you'll go straight down. So you're at the bottom of your road gravels. You'll come across, go up, down this slope, and then the bottom of your area calculation is the dashed line. So the dashed line is the original ground surface. So the amount of fill that's required at this station is this area. So you'll calculate that in square meters. Okay, so if I go back to the spreadsheet, so here's the way you're going to use this spreadsheet. So in the first column, you'll punch in the stations. So the first station, I believe the first cross section that you're given is 0 plus 100. The next one you're given is 110. Then the next one's 120, etc. So all the way down. Notice I'm skipping a row as I go. So the next column, this distance. So what's that? So that's the distance between this station and this station. So these are measured in meters. So what's the difference between 110 and 100? Well, you simply subtract one from the other, right? So the difference, the distance between those two is 10 meters. Notice where I put that number. It's in the row that's between those two stations. Okay, so the next two columns, this is where your end areas, where you calculate your end areas. So I'll highlight it yellow. So we looked at one station 0 plus 110. And if you, using your scale, if you measured the area that I kind of outlined with my mouse, you would get something approximately like that. So that area of the fill on this station is approximately 3.9 square meters. You would do the same thing for cut. Well, when we looked at 110, there was no cut. Let's quickly jump back to the cross section. So there's no cut here. For this exercise, we're ignoring stripping. So you don't need to strip below this dash line. So because the new road or access road surface is filled above the existing grade, you don't have to cut here. So it's all fill. So there's no cut. Okay, back to the spreadsheet. So if there's no cut, put a 0 there, or leave it blank, that's fine too. So you would do this for each station. I'm going to give you also 0 plus 120 so I can show you how this works. At 0 plus 120, there's also no cut, and there's a fill of approximately 1.7. If you get slightly different numbers for the rest of these, right, than I have in my answer key, I won't mark you wrong as long as they're similar numbers. Okay, so you'll fill out all of these white cells with your calculated end areas for cuts and fills. So the next thing that happens, so I'm going to use this row because I've only populated these 4 cells. So this next column I'll put a different color on it. So this is your average end area. So average meaning, so for cut, let's go to fill. Let's do fill first. For the fill, you're looking at the previous fill and then the next fill to get an average for here. So what does that look like? So if I punch in a formula, if I said that cell plus that cell, added them up, and then I averaged them, I divided them by 2. That'll give you the average end area between those two sections. So you would do the same calculation here. So again, we'll go equals. I'll start out with my brackets. So we'll add these two together. They're both zeros. And we'll divide by 2 to get the average. So you'll do that for all of these white cells here under the average column. So what you're getting is average end areas between cross sections. You would also populate these, right, whoops, all the way down. So then maybe you can figure out kind of what we're doing here. So in the volume, so the last 2 columns are the volume. So I'll do fill first again. So again, it's a simple calculation. So average end area fill times the distance between those 2 sections. So times that distance. So what this tells you is from station 0 plus 110 up to station 0 plus 120, we've calculated a fill volume of 28 cubic meters. Excuse me. So again, you'll fill out all of these. So all of these cells are simple calculations that you're doing in Excel. It's only these 2 columns where you have to measure on your drawings. Okay, so it's important to make sure you line things up the way that I've lined them up here. So when you're starting this first question, maybe come back to the video and take a look to make sure that your lines line up. If you look closely, I've only put numbers in white cells. So that's a hint that you're on the right track. If you, for some reason, put a number in a grayed out cell, it's in the wrong spot. Okay, so that's what question 1 is. You'll do all these calculations, right? All these end areas for all the different stations. You'll do your calculations over here to get total fill volume, total cut volume. You'll total them down here. These are the 2 numbers that you insert into these 2 cells here in the exercise. I want to see, though, you need to submit your spreadsheet. Yeah, whether you cut and paste it into the Word document, that would be acceptable. Make sure I got the right. If you cut and paste that spreadsheet that we were just working on and insert it into here so that question 2 and 3 get pushed way down, that's fine. So the top 2 rows would be 0, cut and fill. So yeah, if I check my cross sections, so I'm just on the drawings now. Zoom out. So 0 plus 100, that's our first cross section that we have. So if we look closely on that one, I mean, really zoom in here, there is barely any cut there. You can see the dashed line. It just slightly comes up into the road gravels. So you have a real minor cut area there. So I'm being asked questions, how do I calculate those end areas? You need to have printed out the drawings. So that was a requirement of this class, to print the drawings. If you have not printed, you can use software that will allow you to calculate those end areas. I don't provide that software to you. Everyone should have printed drawings. That was required at the start of this course. You also need a scale in order to calculate, in order to measure your lengths and your depths. So this 0 plus 100 is a real minor cut. There's a tiny little triangle in there. You can also see there's a little small fill here, this corner here as well. So there is fill and cut at 0 plus 100, even though it's really small. So at 0 plus 100, which is this row, so you're going to put a small number in there, you're going to put a small number there. Let's say, for example, those are the numbers. Meaning your average end areas, you're going to have an average cut and an average fill, right? Because if you remember, this column averages these two. So again, if we did this one, it would be the 0.3 plus the 0 and divide by 2. So it's 0.15 of cut, average. Same thing with the fill here. So we'll add the bigger 3.9 and we'll add the tiny 0.1 and divide it by 2. So it's 2.0. These will be blank, yes. Okay, so that is the first question. So it seems like a long drawn out process, but once you get the hang of it, it goes pretty quick. Let me go back to the Word document. So again, once you finish that spreadsheet, you can cut it and paste it into here and just make a big space here and paste it into there. That's fine. So that you're only submitting just this Word document. Okay, so question 2, complete a material takeoff for the access road for the following. So yeah, okay, so assume the road ends at 1 plus 180. So you'd have to look at your drawings to where I mean by that. And assume the road does not have a turnaround. Okay, maybe I should show that. So assume the turnaround at 1 plus 152 is not there. So where are we here? Right here. So back to the drawings. Go to the access road, which is here. Okay, so the question says, assume the road ends at station 1 plus 180. So there's 1 plus 180. So you've got no more quantities to calculate past there. So assume this little bit here is not there. So 0 plus 180 is the end of the access road. The other comment was, assume the road does not have the turnaround at station 1 plus 152. So that's this thing here. So what I'm telling you is, assume the road is a consistent width all the way through here, up to and stopping at 0 + 180. Ignore this widening and this turnaround here. So I believe you're given a width of the road. It's 4 meters wide. So you've got a 4 meter wide access road from 0 + 100 up to 0 + 180. So if I jump back to the Word document, so I've basically given you the surface area of that road. So you need to multiply two numbers together. That'll be your area. So then you are calculating cut and fill volumes. So all these items are required for the access road. So sub-base cubic meters, sub-base tons, road base cubic meters, road base tons, millings, that's the surfacing. So just measured in square meters. And then number of signs, so you're counting the number of signs. So you may be asking, is this a trick question? So question 1, complete the average end area calculation for the access road. So in question 1, we determined the total cut volume and the total fill volume for the access road. Question 2 is complete the following takeoffs for the access road. So we're dealing with the exact same road. So this first question here, what's the total cut and fill? It's the sum of these two numbers. Goes there. Okay, so the details of the rest of this information are on the drawings. So the thicknesses of the varying items here should be on the drawings. So sub-base, base. And you should be able to count the number of signs. Lastly, yes, so question 3 is the last one. So prepare a list of activities. So I'm not asking you to calculate anything, just a list of activities that you, as the estimator, would use in your estimate to construct this road. So what activities? So going back through the PowerPoint presentation would likely give you a good list of activities. So with those activities, include any equipment and labor that you think would be needed with those activities. So things like, you know, the first one's probably layout. You need to lay out the road in order to build it. Maybe this is probably a pretty good list. Your excavation, right? Your cuts and fills would be next. What comes after cuts and fills? And so on. So with each of those scopes of work, with each of those items, I want you to list equipment and labor that you think would be needed for each of those items. Okay, so for conversions, for sub-base and base, I want you to use 2.3 tons per cubic meter. 2.30. Whoops. Okay, any questions? So again, this assignment is due at the start of next class. I recommend you work on it before next Wednesday to ensure that if you have questions, you have time to ask them. So that's all I have for today. So in the meantime, I will post to the news feed that sample tender document. So that 87 pages of the North Vancouver project, I'll post that to the news feed. I'll be online here for a little bit longer, maybe another 5 minutes if there's any questions. The class will end at 9:30 though. So please ask your questions. Yes, you need a scale to calculate lengths and thicknesses on the cross sections. Okay, thanks, Sherwin. You too have a good night. Okay, so I'll post that tender. So the video again will be available sometime tomorrow. I hope to upload it tomorrow morning, hopefully. So question on the scale. So let me bring up the drawing again here, Dylan. Hang on just a minute. So okay, so here's my drawings. So the cross sections, so this is the plan of the access road that you'll use. Notice all the signs that are shown there. And here's the cross sections. So this is sheet 9554. So if I zoom in here, this will tell you your scale. So in the center here is 0. So that line is the 0 line. That's the control line. If you look out to this corner, there's a 10 there. So that tells you from the 0 vertical line out to this vertical line, that's 10 meters. So that's your horizontal scale. So what that also tells you is from 0 to this line is 5 meters. So for vertical scale, so again, you're given elevations here. So here's 58, there's 60. Of course, the one in the middle is 59. So the distance between this line to the next line, so that distance is 1 meter. So let me see if scale is shown in the bottom corner of the cross sections. Yeah, one of them's given. So 250. So actually they might be both 250. Let me look at my hard copies here. Put my scale on it. Yes, if you use, so everyone use scale of 150. So that's the scale you can use on your printed out cross sections. So if we look at, let's go back to 110. So the length of that box is 5 meters. And the height of the same box is 1 meter. So it looks like, just roughly by eye, from the dash line to the underside of the road gravels is less than 1 meter. So that distance is less than from here to there. So then for your length, sorry, for your width of this section, so you're measuring from this point here all the way over to this point there. So you're trying to find the area that I'm outlining with my mouse. Any other questions? Yeah, no problem. Have a good night, Antonio. Okay, I'm going to post the sample tender document. Okay, I'm going to go ahead and stop the video recording.